Circles number one. The goals today are I can find the arc measure, arc length, and sector area when given a central angle, or I can find the central angle when given an arc measure, arc length, or area of a sector. So the or part, that's just backwards. Instead of giving you the angle, you're finding the angle. And the second goal, I can find the arc measure of inscribed angles when given the angle measure, or I can find the measure of an inscribed angle when given the arc measure. So, a couple things before we get started. We need to know a little bit about arcs. So, minor arc is an arc that is less than 180 degrees. You can name a minor arc with 2 points. So, when I look here at this red arc, since it's less than 180 degrees, we could call this arc LM, or you can call it arc ML. You use the endpoints, and instead of putting a line or a segment above it, you put an arc. Now the blue one is greater than 180. As you look here, it's 239. So we would call this. We need 3 points for a major arc. Okay, you must name a major arc with 3 points. So we're going to use L and M are the end, but you need a point in the middle. So you could use T or I either way. All right. So we call that LTM. We could call it LIM. We could go the other way, go MIL or MTL. Now, it is possible to name a major arc with 2 points. You could write the word major arc LM. That way you know which way to go. The problem is, like, if you just say LM, you don't know which way to go. You can go this way on the red or this way on the blue. So it's kind of just generally general practice is if it's 2 points, it's a minor, and if it's 3 points, it's a major, unless you say major arc or minor arc, would be another way to do it. All right. So a central angle is an angle whose vertex is at the center of the circle. Arc angle measure of an arc intercepted by a central angle is equal to the central angle. So if I put here, if the measure of angle GFH is 130 degrees, that's a central angle because the vertex is at the center, then the measure of arc GH is also 130 degrees. Very simple. Central angle and arc are always equal. Okay. Now, if I wanted to find the arc length, you take the central angle, divide it by 360, and times it by the circumference. Now, circumference is 2 pi r, 2 pi times radius, or pi times diameter. Okay. 2r is the same as diameter. So you're basically finding what fraction of a circle this is. It's 130 out of a full 360. So you divide that there, and then you multiply by the circumference, and it'll give you the exact length of that. Same idea with area. Central angle divided by 360 times your area. Now, if you don't remember formula for area, it is pi times radius squared. That's your area formula. So you're going to need to know those. All right, so here we go. Circle ABC, measure of angle ABC is 68 degrees. So that means arc AC is also 68 degrees. AB is 10 units, so the radius is 10. Find the length of AC. So here's my formula, arc length. So I'll just call it arc AC is equal to your central angle out of 360. So that's the the fraction of the whole circle that we're finding times 2 pi r. Okay. So if you go ahead and take your calculator and multiply that all out, it says round to the nearest hundredth on this. So I'm going to do 68 over 360 times 2 times pi times 10. So use the pi button. Don't use 3.14. arc AC equals 11.87. And you know what? I probably shouldn't use equal because I rounded. I should probably use approximately. All right, next one. This time we're going the other way. They're going to give us the arc length. Okay, so here's my arc GH, sorry, it's a little sloppy, is 10 pi. We want to find the measure of angle GFH, so I'll call it X right there. So the 10 pi goes in for arc length. Central angle, we do not know. Oh, we do know the radius is 15, sorry. And then my circumference is 15 times pi, 2 times pi times 15. So I'm just going to make it 30 pi. How's that? Because my diameter would be 30. So let's see here. A little bit of algebra required here. You could, probably the easiest way to do it would be, let's multiply by 360. Let's get rid of this fraction. And there's a couple different ways you could do it, but I'm going to just try to do the least amount of calculator possible. And then since this is times, I could divide by 30 pi. So these pi's will cancel, and then that goes in there. Cancel these zeros. I get 360 over 3 gives me 120 degrees. So same formula, just a little more algebra required with that problem. All right, in circle S, the measure of angle RST is 134 degrees. RS is 19. Find the area of this sector. So we're looking for the area of this piece of the pie right here. Okay, so again, same thing. The area of sector, I'll just put RST as a subscript, is 134 out of 360. That's the fraction of the circle, times pi times radius squared, round to the 100th. Okay, so 134 over 360 times pi times 19 squared gives me 422.14. This problem doesn't have units. Make sure you put units squared. I guess on the other ones, I should have put, on this one here, I should have probably put units. Okay, if it's, feet or miles or whatever, it's linear, whereas this is squared. Okay, so there's that. Next one, same idea here. This time they give you the area of the sector. The area is 3 over 4 pi. That's the area. They give us the central angle. We are looking for IJ, which is the radius. I'm going to use R as my variable. So this is 3 over 4 pi equals 30 over 360 times 3 pi over 4 times radius squared. There we go. No, wait, that's not right. Whoops. Sorry, it's pi times radius squared. I don't know what I was doing. All right, pi times radius squared. There we go. All right, so I don't know. I'm going to do this a little differently this time. I'm going to divide each side by pi to start. So pi's cancel. Let's multiply each side by 360. That gets rid of that. So hit 270 equals 30r squared. Let's divide by 30. And that gives me 9. And then I square root both sides, and I don't need a plus or minus here because we're not going to have a negative radius. So I'm going to get IJ, segment IJ equals 3. 3 units. Okay. All right, the next thing is an inscribed angle. An inscribed angle is an angle formed by two chords. All right, a chord is just any 2 points on the circle connected. So here I have chord SV and chord UV. Two chords of a circle whose vertex lies on the circle. So angle SVU is inscribed on circle T. And what we need to know is the measure of an arc intercepted by an inscribed angle is double the measure of the inscribed angle. So if this angle here is X, then this arc US, is 2X. Okay. Or you could say the measure of the inscribed angle is half of its intercepted arc. So, on the other end, if the arc is X, then this is X over 2 angle SVU. Okay. So either way, it just depends on which one you're given. So, likewise here, with numbers, you can see a little bit better. If SVU is 41 degrees, then arc SU or US is 82 degrees. Okay. So I got to double the angle, the inscribed angle to get the intercepted arc. If I had it the other way, they just gave me the intercepted arc, then I'd have to divide by 2 to get there. Okay, so let's apply this. So if measure of angle PSR is 39 degrees, find the measure of arc PR. Well, that's got to double that, so I double that and I get 78 degrees is this measure. Not the length, this is the measure of this angle. Okay, I would need the radius to find the length. Circle R here, minor arc QS is 120. So this arc right here is 120. Find the measure of angle QTS. So half of that would be 60. Okay. Last thing here, measure of angle MQP is 72 degrees, which would mean that this arc out here, arc MP, would be 144. We double it. And then since angle MNP is a central angle, this angle here is equal to the intercepted arc. So the measure of angle MNP would be 144. All right, that's it for this video.